So quotient law is based on the following. If we wrote something in expanded form, on the top I would have 7 2's. On the bottom, I would have 3 2's. There we go, 3 2's. And when you're dividing something by the same number, 5 divided by 5? 5 divided by 5. 1. There we go. 7 divided by 7? 1. 2 divided by 2? 1. Anytime you divide something by itself, it's equal to 1. So on here, I have this 2 divided by this 2. We cancel them out, and in a sense, they turn to 1's. So the canceling kind of strokes them away, but it also sort of looks like you turn them into 1's. This 2 can turn into 1 with that 2 if you divided them. And this one can cancel out with this one. I like to sort of make Star Wars noise, choo, choo, when you cancel them out. And then what are you left with? You're left with 4 2's times by a bunch of 1's. And, oh, this, you just got back from the washroom. How's your 1 times table? Yeah? 7 times 1? Okay, here, you can sit down. You're good. All right. Wow. That's like, that's pressure, right? Yeah, very good. So we're left with 4 2's, which is 2 to the 4. Okay? We could do the same thing with the next one. Okay? So here, on this one, Kale, try to predict what you think the answer will be before I write it down. So if we wrote it in expanded form, we'd have and then, of course, 3 divided by 3 is 1, so choo, 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 those would cancel out. And we're left with 3 to the exponent of 4. Now, number 3, I'm on 4's. If I had this, I don't want to write it out in expanded form. Can you see why you don't want to write it out in expanded form? Too much. To write out 100 4's all multiplied together. Too much. It's going to be, what's the answer going to be? Yeah. Because 50 of them would cancel out, and you would be left with 50 of them afterwards. Now, what you just did was the quotient rule, saying that since I understand what's happening, things are canceling out and equal to 1, I see that the shortcut is that of the 7 2's that were on the top, 3 of them get canceled out. That will leave me with 4 of them. So the quotient rule says that, and it's right here on the next page. Wait for it. Wait for it. That when you're dividing, and you could write the dividing that way, but as you get higher in math, you write dividing more like a fraction. If you have x to the m divided by x to the n, where m and n are numbers, all you have to do is subtract the exponents because a bunch of them will cancel out. Things that are important. Oh, I can't use my highlighter because that, we know for sure, freezes things. Maybe I'll, oh, but I'm so tempted. Oh, it worked. Okay. This is very important. This only works if the bases are the same. Then you can subtract the exponents, but you never do anything to the base. The base stays the same because we saw already the 3's cancel out. You're still left with 3's. So the base still stays the same. You're just left with less of them. Oh, man. You should have, because we're making these videos, right, you should have your phone out with music ready to go, and then you could just, when it happens, he could just pump the music in the background. Or he could just sing. So, simplify, if possible, using the quotient law. And often, you'll see these questions, and I get you to write this into your notes. So right after this part with the quotient law, write it in that it says, write as a single power. Because you might get a question on a quiz that says, write as a single power. And that means you want to simplify it and see how many are left. So for example, this first question is not a single power because we have a power on the top and a power on the bottom. But because they'll cancel out, you'd be left with how many 4s? 5 of them. This is a single power. But I noticed it on your last quizzes and your last test that one of the things that's hard in a math class is you don't pay attention to the instruction words. And then when you get to a quiz, you're like, oh, what does this question mean again? It's not that you can't do the math, but you forgot what the instructions words are. And that is frustrating as a teacher because I'm like, I know you know how to do the math, but now that we're on a quiz or a test, I'm not supposed to help you with that part. So instead, the best thing I can do for you is really point out, these are the key instruction words, and this is what it means. So if you're paying attention during class, then hopefully that means that you can do better on those quizzes and tests. Does that make sense? All right. Are the bases the same? Yes. So things would cancel out, and you would be left with just a -7. You could put that in brackets, or you wouldn't have to. Are the bases the same? Yes. A bunch of them would cancel out. I like to imagine them canceling out whenever possible. Can you imagine 22's on the top, 18 2's on the bottom, canceling out along the way, and being left with only 2 of them? But sometimes we can't visualize things perfectly, and that's what happens in D. In D, I can visualize 3 multiplied by itself 3 times, but that negative is a problem because I can't visualize that the same way. But since the bases are the same, I can use the rule. The rule says if your bases are the same, which they are, and you're dividing, which we are, then you can subtract the exponents. So it would be 6 minus a -4. And then you have to ask yourself, how do you subtract a negative? Subtracting a negative is the same as adding. So then you would get 3 to the 10. So these first 4 examples all dealt with numbers. You know what I learned over spring break? Do any of you have, this is totally off topic, have any of you ever seen one of these pens that the ink is erasable with friction? Okay? I just found out that if you write something and erase it with the friction pen, then stick it in the freezer, the ink will reappear. That is cool. Apparently, the way that they work is the heat is what makes it erase. And the cold would make it reappear. So you can like write all sorts of secret messages, erase them, hand them to another person. They could stick it in the freezer. A student said that, did you know that that works? So I was like, Oh, so I tried it. I erased it. I stuck it in the freezer. I forgot about it for at least 3 weeks. Then during spring break, I was like looking for ice cream. Found the note. And I was like, oh, it worked. All right, here's the next 3. Now we're moving to variables. So we can do the same thing we do with numbers, we can do with variables. The same rules apply. The bases have to be the same. You see in the first one, the bases are x's. Are they the same? Absolutely. So if you wrote it in expanded form, can you imagine 5 x's all multiplied together? 3 x's on the bottom. Can you imagine them canceling out? How many x's would be left? 2 of them. The next one. Okay? They're not the same base. We can't do any of our rules here because of that. What could we do? We could write the top as, I like this, actually, showing you some other cool math stuff. Top is 12 times 12 times 12 times 12. The bottom is 2 times 2 times 2. Okay? I'm guessing your 12 times 12 times 12 times 12 is not so good mental math. No? That would definitely be a calculator, right? But if you wanted to simplify this a little bit, can you see that 12 is 2 times 6? So I could change each of my 12s to 2 times 6 if I wanted to. And then my bottom is still 3 2's all multiplied together. And if I wanted to simplify, I could do that a little bit. And then I'm left with 6 times 6 times 6 times 6 times 2. I guess technically I could write that as 2 times 6 to the 4, which we simplified it a little bit without a calculator. But a lot of questions like this, you could use your calculator. Whew.
You also just cancel, what if you did it this way? When 2 can go with
Yes, and right 6 is, yeah,
6 times 6 times 6
times 12. Yes, it's the same thing because that last 12 you could make 2 times 6 and then it would make this same thing. Okay, more than one variable. If you have more than one variable, you do each of them the same. A divided by A. Well, you guys were really good with 7 divided by 7 and 3 divided by 3. Can you see that A divided by A would just be 1? So you could cancel them out and make little slashes that look like 1s. So the answer to this one, you have 2 B's on top, 1 B on the bottom. You'd just be left with, wait for it, maybe, maybe not, a B. Okay, there it is. Oh, nice. This is to make me feel good, to make me feel like I'm faster than a computer, right? They gave me a slow computer just to help me feel good about myself. All right. Same thing with numbers. When you're dividing, you can divide your numbers. What is 10 divided by 5? 2. So we can say there's going to be a 2. How many x's are going to be left? 5 of them. You guys are doing great. On the next one. Could we use the law here? No. We can only use the subtracting thing if things are exactly the same. Okay? If the bases are different, the best you can do is write it in expanded form. And then, would you agree that 4 divided by 2 would leave you with 2? And this 4 divided by this 2 would leave you with 2? And so you're left with 2 times 2, which is, 2 squared, which is 4. Check this out. If the exponents are the same, you could, and we'll see this later why, could move the exponent outside and do the inside dividing first. And now you've learned the product rule, which is if the bases are the same, you can add the exponents in a powered. And you've learned the quotient rule, where if the bases are the same and you're dividing, you can subtract the exponents. And now we can combine them together. Multiplying and dividing. How many 5s would there be in the end? How many 5s would there be? We need to know the exponent. Okay? So in order to find that, we might need to do this in more than one step. How many 5s are there on the top? There's 7 5s on the top. Good. That's your product rule. The bases are the same. You can add your exponents. And now, wait for it. Maybe there it is. Now we're dividing. What's the rule for dividing? The bases are the same. We can subtract the exponents. This is where you might want to show your work because you're subtracting a negative.
Would you require them to first put 5 to the 7 over 5 to the 7?
I would recommend first doing that because this would be a 2-mark question. Okay? If you try to do it all to the 1, all in one step, and you accidentally went 7 minus 4, because you saw the minus 4, and wrote 5 to the 3, I don't know what you did. I'd have to give you 0 out of 2. But if you showed that you knew that there was 7 5s on the top, that's one of the marks. And then if you make a silly mistake and not write 5 to the 11, because subtracting a negative is adding, then you might only lose half a mark. So showing your work could change your mark from 0% on a question, because 0 out of 2 as a percentage is 0%, to 1.5 out of 2, which is 75%. That's huge. Another thing that some people do, okay? So I use the quotient rule here. I've already told you about the negative exponent. We did it at the beginning of class. That a 2 to the negative 4, negative exponent moves it to the other side of the fraction. So 2 to the negative 4 moves it to the bottom to 2 to the positive 4. If you have a negative exponent on the bottom, I could have moved it to the top. And if I move a 5 to the negative 4 to the top and change it to a positive, then I'd have 5 to the 7 times 5 to the 4. And now we have our adding rules. And we get 5 to the 11 as well. So you have options with the negative exponents. You could have kept the negative and done your math with the negative number, saying, I'm dividing powers with the same base, I can subtract my exponents. I get 5 to the 11. Or I don't like negative exponents, so whenever I have a negative exponent, I move it. Could have moved it to the top right at the beginning. 5 to the 4, 5 to the 3, and then another 5 to the 4. And then be like, oh, I just have to add up all those exponents, and I get 11 that way.
Would you do it that way?
Yeah, I probably would. I like, because dealing with positive numbers just makes life easier. You make less mistakes than when you're working with negatives. Okay? So I like to do that. On the other side, you need to practice working with negatives so you make less mistakes. So it's kind of a bit of both that are important. Yeah, try these 3 on your own. I'll put up the answers a bit. It does say simplify, so that means use your exponent rules as much as you can. And then afterwards it says evaluate, and evaluate means come up with a final answer. Try to do it without your calculator, and then afterwards you can check with your calculator. I will put the answers up. Don't look. Only look once you're done a question. I will circle the evaluated ones. Have I showed you the mental math way to easily do 3 to the 4? 3 to the 4 is 3 times 3 times 3 times 3. And most students will do 3 times 3 get 9, times 3 get 27, and then go times 3 and take like 25 to 40 seconds and then get 81. Okay? The easier way to do 3 to the 4 is to circle these and say, it's pretty easy to do 3 times 3. That's 9. And so this is just the same as 9 times 9. And that's a lot quicker than doing 27 times 3. And you get 81 that way. Okay. Mr. Shirk is handing out some practice questions. We won't get done them. We're only going to take about 5-10 minutes to start them. Leave them for you for homework. There's a cheesy joke involved, which is always good.